Hello genius mathematicians and welcome back to my channel. In today's video, we are going to learn on the topic of growth and decay. But before we get started, don't forget to like, share and subscribe to my channel. So let's get started.
Okay, now let's look at how to do this question. A farmer monitoring an insect plague notices that the area affected by the insects is given by this equation, where n is the number of weeks after the initial observation, and we have to estimate the time taken for the affected area to reach 5,000 hectares. So basically, we have to find n. But before we start, let me tell you an important log rule that will be helpful here. When we have a to the power of c equal to b, we can write this as log a b equal to c. Keep this in mind. It will be helpful here. So let's start. What I'll do first is take down all the important information that is given. So firstly, we have the equation, and we have the area. So an is equal to 5. Now simply I'll just plug in an into this to find n, because we have to find the time taken. So we'll have 1000 multiplied by 2 times 0.7 n equal to 5000. I'll take 1000 to that side. 5000 divided by 1000 is just simply 5. So we'll be left with 2 to the power of 0.7 n equal to 5. Now we can use this rule in this because we have a to the power of c equal to b. We can turn this into log form. We have 0.7 n, which is our c, log base 2 of 5. Now we have to solve for n, so if we send 0.7 to that side, we'll have log base 2 5 divided by 0.7. And solving for this will give us the value of n as approximately 3.32. So using this information, we can say that it took around 3 weeks and 2 days for the affected area to reach 5,000 hectares.
Now let's look at the next question.
Irana has 5,000 pounds to invest in an account that pays 5.2% interest compounded annually. Find using logarithm how long it will take for an investment to reach 20,000. So to do this, we can use the compound interest formula, which is A is equal to the principal amount 1 plus R over 100k to the power of kn. Here R is the rate, P is the initial amount invested, A is the amount we get out, N is the number of years, and K is the number of compounding periods in a year. So let's take a look at what this means. If we have a quarterly compounded interest, then we'll have 4 compounding periods. If we have a half yearly compounded interest, then we would have 2 compounding periods. And similarly, if we have annually compounding interest, then we only have 1 compounding period. So we can just simplify this equation and write it like this. Since k is 1, 100 times 1 is 100, and since k is 1 here, 1 times n is n. Now, to solve this, first let's list down all the important things. So we have our principal amount, which is £5,000. We have our rate, which is 5.2%, and we have our amount, which is 20,000. What we need to find is n, the time it takes for the investment to reach 20,000. So let's plug everything into the equation to find n. So we have 5,000, 1 plus our rate is 5.2% over 100, n equal to 20,000. Take the 5,000 to that side, we'll have 1 plus 5.2 over 100, n equal to 20,000 divided by 5,000. Can cancel out 3 zeros with 3 zeros. 20 divided by 5 is simply 4. And we can also simplify this. 1 plus 5.2 over 100. So 5.2 over 100 is just 0.052. And 1 plus 0.052 will give us 1.052 to the power of n equal to 4. Now here we can apply our log rule. So n is equal to log 1.0524. So our n is approximately 27.3 years or 28 years.
I hope now you got the concept and you can do more questions by yourself. Thank you for watching and see you next time.